Hi everyone, this is Indra. Welcome back to my channel. Today in this video, I am going to discuss about the geometrical meaning of the derivative of a function. Here, this is the topic of today's discussion. Today we will discuss about the geometrical interpretation of the differentiation of a function. Please remember that the derivative of a function always gives the slope of the tangent. If we differentiate the given function, then the result always gives the slope of the tangent, the locus of the slope of the tangent. Okay, and here I have taken one example to illustrate this topic. Here I have taken a function sine of x and then differentiate it to get the cosine of x. The derivative of sine of x is just cosine of x. Here in this video, I am going to just verify that the derivative of a function gives slope of the tangent or not. I am just going to verify this statement. Please watch this video till the end so that you will be very clear about this topic. Okay, let me open the GeoGebra software on which we can draw the graph of any function. Okay, let me just open that software first. Okay, here this is the GeoGebra software, and our function is just the sine of x. First of all, let me graph the function sine of x. Okay, this is the graph of the function sine of x. Here we can see that the sine of x always passes through, this is sinusoidal curve which passes through the origin. Here this is the graph of the sinusoidal function. Okay, we are going to verify that the slope of the tangent on this graph is just the derivative or not. Okay, first of all, let me make the slide tool here. Let me take the one slider. I'm going to just animate this. Let me just take the one slider first here. Okay, name of this slider is just A. We can use the any name, and range is from, let me take the range from -10 to +10. Okay, and here the sine of x, in sine of x, the x is measured in the radian. Okay, let me take the number here. Okay, here I have made the slider here. This slider can be moved here. It takes the value from -10 to +10. Okay, this is just the slider, and here the in slider the value of a is given here. The value of the a is given. So let me take the next point on the graph, such that the point is the x coordinate, the abscissa is just the a, and the ordinate is just the f of a. Okay, let me just take this point on this graph. This point will be on this sinusoidal graph. Okay, let me just take this point here. We can see that this point. Okay, let me move this point. Okay, let me use this move tool. Okay, let me just slide this point here. This point A. Here we can see that this point A corresponds to this value from -10 to -10 to +10 according to the slider. Here I have just taken a point which can be moved. This point can be moved. Okay, let me show that this is movable point. This is movable point on this graph. Okay, and it goes from -10 to +10. We can take the next range for it. Okay, here I have just taken from -10 to +10. This is just the movable point. I'm going to just animate here. This is the point on this graph, and let me draw the tangent at this point. Okay, let me make the tangent, and then I will find out the slope of the tangent. Okay, let me use the tangent tool. First point at which the tangent is going to be made, and the curve is here, this, and this line, this black line represents the tangent line at this point A. Okay, let me animate this once again. Okay, here this point is movable point, so due to this movement of this point, the tangent also moves here. We can see the tangent at many points on this graph. This is the tangent here. This is moving here. Okay, and let me find out the slope of this tangent. Okay, let me evaluate the slope of the tangent. Okay, here we have the slope tool. Okay, let me use that slope tool. Slope of this line. Okay, here the slope is here represented by the small m, and let me animate this once again. Here the slope is calculated. Here we can see that the slope m is calculated at every point on this graph. Here the slope is represented by small m here, and m represents the slope of the tangent. Okay, let me graph that. Let me find out the locus of, okay, I am going to just evaluate the locus of the slope of this tangent. Okay, so let's take the point is the a comma m. Okay, I am just going to find out the locus of this slope of this tangent. Okay, locus of the slope of the tangent. Okay, okay, here we can let me, this is just the point b. Okay, here we can see that this point b, this is the point b, which represents the locus of we can move this tangent. Okay, this point b represents the locus of here this moving point b represents the locus of this tangent line, locus of the, sorry, locus of the slope of the tangent line. This point represents the locus of slope of the tangent line. Okay, let me trace this point. Okay, let me trace this point b, then we can easily see the locus. Okay, let me just animate this. Here this dotted line here, this is just the locus of the point b. Point b is defined as the point of the slope of the tangent. Okay, this black dotted line represents the locus of the slope of the tangent on this same graph. Okay, let me stop this once again, and let me use the next color for this locus. Okay, let me we can change the color. Okay, let me use the next color for the locus of the slope of the tangent. Let me use the blue color. Okay, here okay, let me use the next color to it. Okay, we can change the color. Okay, we can easily change the color by moving to the settings. Okay, this is the point b, and let me use the, for the sinusoidal graph, let me use the next color. Okay, next color, this is just represented by the red color. Okay, here this sinusoidal graph, the graph of the sinusoidal function is just denoted by this red graph, and the point b, is here going to represented by the blue color. Okay, let me just animate this once again. Okay, here we can see that the tangent is here, the tangent is moving along the given curve, and here the locus of the slope of the tangent is here represented by this dotted path, blue color dotted path. Okay, here this is just the this blue color path just gives the slope of the locus of the slope of the tangent. Okay, and let me, we know that first of all let me make, okay, first of all let's take the next function, which is just the derivative of sine of x. Derivative of sine of x is just the cosine of x. Let me just plot this here. Let me plot this cosine of x. Okay, we know that the derivative of sine of x is just the cosine of x. Let me just plot the curve of cosine of x on this graph. Okay, let me just plot it, and let me represent this by the function as. Okay, let me use the next color to this. Okay, let me use the next color for the derivative function. Okay, let me use the which color. Okay, let me use the black color. Okay, here this black color curve, we can see the here the black color curve is just the curve of cosine of x. Cosine of x is just the derivative of sine of x. Here we have plotted here the curve of the derivative of sine of x, which is cosine of x. And let me just verify that this locus of the slope of the tangent gives the curve cosine of x or not. If the geometrical meaning of the derivative of a function is just the slope of the tangent, then the locus of this slope of the tangent should coincide with this function h of x. Here h of x is just cosine of x. If they coincide, then the slope of the tangent, the locus of the slope of the tangent is just the derivative of the function. Okay, let me just verify that. Let me animate this. Okay, here is the coincide. Here the locus of the slope of the tangent is exactly coincide with the derivative of that function. So we can say that the derivative always gives the slope of the tangent at the particular point. Okay, here we can easily see that. Okay, let me make one checkbox. Okay, let's say here, and this is just the derivative. I'm going to just make the derivative checkbox. Okay, checkbox for the derivative function, and the derivative function is here just, which is the derivative function here. Here just represented by the function. Yes. Okay, let me just make the checkbox here. This is the checkbox. We can hide on hide. We can show or hide for this derivative function. Okay, let me just use this checkbox. Let me use this checkbox. We can let me use this. There is some problems occur. We can make the checkbox for the derivative. Okay, here we can see that. Here. Let me hide this derivative function. Okay, here the function is hidden here. The function is hidden. The derivative function is hidden, which is cosine of x. Let me show this. Okay, here the derivative function is shown. We can make the checkbox. This is called the checkbox. Okay, let me move these two boxes together. Okay, we can shift this. Let me just shift this. Okay, here we can shift this graph. Let me animate once again. Finally, here the slope, the locus of the slope of the tangent is exactly coincide with the derivative function. So we can say that the derivative always gives the slope of the tangent here. Okay, let me hide these unnecessary parts. Okay, once again. Let me check this check box is operating or not. Okay, this is operating here. This is hidden here. The derivative function is hidden. We can show just by clicking here. Okay, it is operating here. Okay, let me hide this part. Okay, this is the full drawing. Okay, here we can see. Okay, let me just animate this. Okay, animation. Okay, here we can see very beautiful drawing. Here we can see that from this animation we can conclude that the derivative of the function always gives the slope of the tangent at the particular point. Here in this figure, in this drawing, the locus of the derivative of a locus of the slope of the tangent is exactly coincide with the derivative function, the path of the derivative function. Okay, here let me stop this animation once again. We can stop, and let me check that this checkbox is operating or not. Okay, let me go to the checkbox sections. Okay, here in this way we can say that this is the illustration. Okay, this is just the graphical representation of the derivative of the function. The graphical interpretation of derivative of a function is just the slope of the tangent. Okay, let me just any minute 1 second last time. Okay, here we can see this animation. This is just the graphical interpretation of derivative of a function as a slope of the tangent. Okay, let me stop. In this way, we can prove that we can say that the derivative of a function always gives the slope of the tangent. Okay. In our next video, we will discuss more about such types of the interesting geometrical interpretation. Please keep watching, keep loving this channel. This much for today. Thank you.